Hello everyone, welcome to Code Crafters Lab. So now we are trying to do the optimal solution from GCD of two numbers. Okay. So till now what we have tried, we have tried our brute force approach where we are running our loop from I equal to 2 to we are finding the minimum of n1 and n2, and we are trying to find the like n1 modulo I equal to 0. This is like a formula to find the divisor. Okay, and then n2 modulo I, this is how, and putting the and condition, we are trying to find the common divisors out of these two, and we are adding it in the GCD variable. And why we are not trying to do any comparison, because anyway we are running loop from 2 to minimum of both, so anyway it is incremental. So later we have tried to do somehow in a better way by traversing it from reverse side, because we want to find the greatest, right? So whatever comes first, we are returning that as a GCD, right? Then now coming back to the optimal approach. So there is one algorithm, Euclidean algorithm. You can try to search it on internet also. So what it states that GCD of n1 n2 equal to GCD of n1 minus n2 comma n2. Okay, when n1 is greater than n2. Okay, so in this particular example, n1 is 35, n2 is 10. Okay, and GCD is 5. Okay, so we will try to solve it using Euclidean's algorithm. So what will it become? N1 equal to 35, n2 equal to 10. So what it will do? It will do minus 10 from n1. So n1 will become 25 and it will become 10. Then again minus 10 from the n1, it will become 15 and it will become 10 again we'll do minus 10, so it will become 5, it will become 10. Now what we'll do minus 5 from 10, so n2, so basically it will become 5 and 5. Now either of one you can make it as 0 and other one will become 5. So at this point, when one of these two numbers becomes 0, the other one is nothing but your GCD. Okay, so this is how this particular algorithm runs. So if we try to write a pseudocode for this, how it will become? So while n1 is not equal to 0 and n2 not equal to 0, we will run a while loop. So inside that, what we'll do, if n1 is greater than n2, what we'll do? We'll do n1 equal to n1 is greater, right? N1 is greater than what we are doing, n1 minus n2, right? Else n2 equal to n2 minus n1, right? If n2 is greater, where n2 is greater, then we are doing n2 minus n1, right? So this is the condition. And after that, what we'll do, if n2 equal to 0, if n2 is 0, if my n2 is 0, then n1 is the GCD, so return n1. Otherwise n2 is the GCD, return n2, right? But this is how we have completed our algorithm. Okay, but in this case also there are some issues. Okay, so let's say your n2 is 1 and n1 is 100. So we are going to reduce it one by one, minus 1 till we reach the last number, right? We have to reduce it by one, right? Let's consider one example, n1 equal to 100 and n2 equal to 15. Okay, so in this case we are reducing it till my n1 becomes 10 and 2 becomes 15, right? Till that time we are reducing it, right? So this is like a time taking approach, right? So why we are reaching 10 is nothing but reminder. When we do, let's say 100 right? 100 modulo 15, so it will do like 15 into 6. 15 into 6 is nothing but 90, so 6 times you have to reduce it, right? That is what we are doing here. Like 100 minus 15, then it will become 85, then again 85 minus 15, then it will become 60. So we are doing it till 10. It is nothing but 15's multiplication, so 15's multiplier we are doing here, right? So can we optimize it? Yes, we can. What we have to do is nothing but we have to do only one thing, right? We have to do here n1 modulo n2, right? That's what we have to do. So this is how we can optimize it. If we are doing it, it is nothing but like it is going to give you the remainder. So that is what we needed, right? We don't have to reduce it by number. So in this case it is less iterations, because 15 into 6 iterations only, because n2 is 15. But if n1 is 2, then it will take a lot of time to reduce it till 0, right? So let's try to code this now. So this is how we can reduce this. Also, like talking about the time complexity here, it is nothing but O of log of minimum of n1 n2, and space complexity is nothing but O of 1. So let's try to code this. I'll just remove, we'll write one for while n1 not equal to 0 and n2 not equal to 0. Okay, after that, inside that what we are doing, if n1 is greater than n2, if n1 is greater than n2, what we are doing, we are doing n1 equal to n1 modulo n2, right? Else n2 equal to n2 modulo n1, right? And after that, what we are doing, if n2 equal to 0, then we will return n1 as GCD, else l2 n2, return n2. Let's try to run this. Yes, accepted. So yeah, we have solved this problem in 3 ways: brute force approach, then better approach, and one more optimal approach, right? Hope you have understood. Please subscribe to our channel, and thank you for watching.